In this screencast I'll show you how to use the Gibbs Reactor unit operation. So over on the PFD palette, click on Reactors, then click on Gibbs Reactor, and then click on the flow sheet to place the Gibbs Reactor into the process flow diagram. Now we should point out that the Gibbs Reactor simulates a chemical reactor by solving the heat and material balances based on minimizing the free energy of all the components in the reaction. So the reactor determines the distribution of all the components which is expected at chemical equilibrium for the system. No prior knowledge of the chemistry of the system is required, and the reaction stoichiometry doesn't need to be defined. So that's quite a big advantage, not needing to supply that information. But the caveat is it's only hypothetical. What really happens will depend on the reaction kinetics, and so the result may or may not be possible depending on more detailed information. Okay, we need to connect up an input stream, and we also need to connect an outlet stream. Now for the input, going to put a total flow rate of 7,000 kmols per hour, and it will be 25% nitrogen and 75% hydrogen, and we're going to simulate a reaction to create ammonia. So press OK, and the temperature of the stream is going to be set at 505 Kelvin, and the pressure will be set at 100 bar, so 10,000 kPascals. Now it's important to note that in the component selection we have got nitrogen, hydrogen as the reactants. We've also had to specify the product that will be generated. Okay, and then we also need to, we can just specify a fixed temperature here of 570 Kelvin. Okay, we'll press OK on that. Everything's ready to run. In fact, this was ready to run before, but I wanted to go into the reactor and just change the specification slightly. As you can see, there are a number of different parameters that you can set here. There are also other bits of information that you can adjust. For now, we'll just stick to simply fixing the reaction temperature. Okay, we can run the flow sheet, and then we can get information about the outlet stream. We can see that its temperature is the same as the reactor, that's fine, so is the pressure. We've got a flow rate here which has gone down. That's due to the reaction stoichiometry that the reactor's worked out. And we can also go to the material balance and see that we've generated some ammonia. Okay, if we close this window now, we can also review the data for the reactor. We get some limited information here. If we close this and click View Results, we bring up a window that will give us more information about the inlet and outlet streams, about the components in the streams, about the fraction conversion. So we've achieved 0.7127 fraction conversion, or 71% conversion, and we see this additional information. Overall, that is a quick introduction to the Gibbs Reactor and how you can use it in Pro 2.